Hey, and welcome back to this series where we were going to make tic-tac-toe games with a twist. In the previous episode we focused on the AI, which is basically unbeatable and quite fun to play against with. But in today's episode we will focus on making a tic-tac-toe ultimate game. I will explain tic-tac-toe ultimate in a moment, and this is the end result we're gonna make. Tic-tac-toe ultimate, or maybe some of you know as Super Tic-Tac-Toe or Strategic Tic-Tac-Toe, is a variant of tic-tac-toe which also plays on a 3x3 grid. But this time in each cell, the marker will be defined based on the outcome of again a 3x3 grid. The rules of the pattern search remain the same, but there is a catch on where the opponent can play. The first move can always be played on any of the grid cells. But once one move is made, the opponent is forced to make a move relative to this location. For example, if X puts its marker in the middle grid cell in the middle position, O is forced to place an O in the middle grid cell too. If O puts its marker then in the top left, X is forced to make a move in the top left grid cell. But there are two exceptions. If there is a win or normal moves possible in the grid cell relative to the previous move, the opponent is allowed to move in any of the available grid cells which are left over. This will continue all the way until someone has won on the main grid, or normal moves are available and the game ends in a tie. Now let's get this work in the code. We will start by making an ultimate class. In this ultimate class we will define all the rules and set everything for tic-tac-toe ultimate. And because we want to render and update, I will also implement here the iGame object. We can import all the unimplemented methods, and I will remove quickly the comments. And instead of having one grid, I will create a new list for the grids. So create a new array list from our grid, called grids equals to a new array list with the size of our main.size actually, because it always has to be the same as the normal tic-tac-toe board game. Then we also gonna need a main grid, so we'll have one grid which I will call main grid, and this grid is gonna be on top of all of these smaller grids. So eventually this is the grid which is playable to get a win or lose or a tie. Now let's create a constructor. We'll say public ultimate. I will first add one grid, so we can first work on making a smaller grid. So therefore we can say new grid and our main.width divided by the rows. And this means that eventually if this is going to be our size, our grid will fit in every spot of our main grid. And because we don't have a size added to our grid, I will add it to the constructor. I'll also create a new local variable, or a new variable in this class called size. And I will say this.size equals to size. You now have an array here because it has the same naming. I will call this cell size because that's basically what it is, and add it to the fields. And this size we want to now set instead of all the width and height which is set in this class, such as here. So therefore we can say Ctrl F, and we're gonna replace every main.height in this example to size, but also the main.width, and replace all. So now we should have one small grid in the top left. But of course we are not updating this yet. So in here I will first make a for loop to update all the grids. Not this for loop, but we can make the for each. We'll say grid.update. And we can also render. So here for each grid.render. And now we're gonna break our game panel. We don't need this anymore. We also don't need this anymore. So we can remove all this code for now. And I will say here a private ultimate. And ultimate equals to new ultimate. Can close this one. And we're gonna update the ultimate, so it will eventually update the grid. And update it here too. Oh, and render it here too. Nope. We will also move the mouse behavior to the ultimate. So we'll say ultimate.mouse released. We will say E. And we can copy all this and generate this method through here. And in here we can copy it. And for now, we can actually do the for each. And we can at least say the mouse released for each grid in this case. And this we don't need at this moment. We're gonna add them later, but there's different rules now for the ultimate. And we go back to the game panel and we can keep this. I will remove this line. And we can remove this for the mouse moved. And here say ultimate.mouse moved with E. And create this method too. And in here we will do the same again, but then mouse moved. Now if we should run this, we should have a smaller grid, which we have. And it looks a little bit silly with the big or the thickness. So let's change that as well. I will set the thickness now to 6. And I will also change something in the code here. One thing is also we can remove this line because it's actually not really needed since we are already calculating the X and Y. So we'll remove this X and Y to the I and here to this. And for the size I will say like the very first line and the last lines, so the box lines, I want them to be a bit thicker. So we will make a new variable and we'll call it thickness. And in the beginning it's the same as the grid thickness. And then we will say if I equals to 0 or I equals to our main.rows, we will say thickness times equals 2. So it's twice as thick as our usual. And then we can apply this thickness instead of the grid thickness. And now we should have a smaller block with a thicker outline. So eventually we will have like bigger outlines here. And now in the ultimate, because we know it's now working, we're gonna make a for loop here. So we'll say for and the main.size, which is in this case 9 with the rows on 3. And we will say grid.add a new thickness, but we need to know the start positions. So I will first create an int x equals to y modulo our main.rows and define our y as well, which is our I divided by main.rows. And then we have our starter point. So herefore I will first say x and y because we're gonna need those starting positions as well eventually. Or wait, actually we just need this x and y and we can calculate the positions by the size we're gonna give here. So therefore we're gonna go back again here and I will say in the grid add the int x and int y. And then here we will say private int x, private int y, but also create 2 new ones to calculate the start x. And private int start y. And what this is gonna do is we're gonna start the position of each grid in each position. So this dot x equals to x, this dot y equals to y, and then start x equals to x times the size, and start y equals to y times the size. And then we also gonna need them here. Start x plus our start positions for the new placement, and also start y for the y position of the placements. And then we will move down where we render the grid, and here we will say start x plus, and instead of the 0 we will gonna say start y, and the same here. So here start x, and here start y plus. And I think we're gonna have a little problem with our markers because they won't have the starter. Let's first test this out. We now have this working, and as if I place this, you will see we cannot really play. It will keep the same positions as you see here as well. So let's fix that quickly. So here where we create the marker, we will now also add the start x and start y. We will move to the marker, add these here as well. So here as well, this dot x, start x equals to start x, and the same for start y equals to start y. And then add these up to the position here. So here start x plus, and here start y plus. And we also need to change this size. So we will actually also add the size here, int size here as well. And here this dot size equals to size. And we will change this size actually here to this dot size. And then in the grid, only need to add size again. And let's see if it works now. Everything is working as we were expecting, at least. But as you can see, each grid is playing against himself. We also have the end game animation, which we don't need anymore. At least not for the specific smaller grids. So let's remove those. I will actually, this game over overlay, I will move it to our ultimate. So we can here eventually define if a game is over or not. And in here we can keep it to the main.width and height. And we can actually also say our win type equals to our main grid dot get winner. And this is what we're gonna define now as well. For the grid, I will comment this, by the way. We will need to store the win line. So we can remove this part and say here, I will actually add it up here next to the other line, next to the other list. Array list. For our marker, it's our win line. Now we have our win line here. We can also return a get winner. So let's say public int get winner. And for this winner, we're gonna first check if the win line is equal to null. If it is, we're gonna return -1, and else we're gonna return the first marker from the win line. So get 0 dot get type. So now in the ultimate we can. Well, we have actually prepared it. So eventually, if we have a win, so in here we can check if our main grid dot game end. And if this game is end, then we will draw this end game overlay with our graphics. With our graphics render. So this is not working yet, but we can kind of assume that this is how it's gonna work. When this main grid is end, our game is over, and then we're gonna check who is the winner from this main grid. So now let's focus on our marker index actually, because currently if you saw us playing, we define the marker index still in each of the, oh, we have a error here, because we haven't main grid defined yet. Well, we can actually make it as well. Say main grid, new grid, and this we can actually place on 0 and 0 with our main dot width. So it's going to be the full size, and we're not going to update and render this yet. So we won't notice it yet, but we eventually will. And as you can see, now it's O, so well, it's now X here as well. But here it now should be O's turn, but it's still X. And here it should now be X turn. And now it should be here O's turn. But it keeps keeping hold of what the marker index is per play in the specific cell or in the specific grid. But we want to have this whole grid to define whose turn it is. So let's change that. We just added this marker index. What we're gonna do now in the mouse release is we're gonna check in which grid we gonna place our marker. And we're gonna update our marker index by that and define which grid is gonna be the next active grid. So therefore I will say here placement selected placement equals grid.mouse released, and we will add our marker index here. So it will know that we released on this specific grid with our marker index. And if the placement is not null, selected placement is not equal to null, it means we selected a valid placement where we can place our marker. What we also will need is we're gonna define the X and Y of this specific position, so we eventually can move our opponent to a specific grid to make its next move. So was an active X and active Y. And let's predefine them as -1. And then here we will say active X equals to our selected placement dot get X index, and our active Y is equal to selected placement dot Y index here. Then we're gonna say our marker index is gonna add up, so plus. And we're first gonna check if the grid has a winner. So grid dot get winner. And if it does, actually is bigger or equal than 0. So the winner, because otherwise if it's a tie, it's gonna be -1. So if it's 0 or 1, we're gonna place a marker in our main grid, which is based on this grid get X. We will define this because we just added it. And we will also get the Y from it. So it knows what the specific position is from this grid to place our marker. And then we're gonna add the winner here. So it's gonna be either X or O. So let's create this getter here. And we'll remove this and we'll return our X. And this is gonna be an int. And same for our Y. This is what we defined up here. So let's get back to our ultimate class. I forgot to add here place marker. And we're gonna create this new place marker with the X and Y. So let's create this method as well. Let's see, it's gonna be 3 integers. And I will add this to the other place markers. So in here I will say X and Y, and we will say the marker index equals to winner And we're gonna place the marker at our X and Y. I set the marker index to the winner, so it's gonna set it here to the marker index we want to set on this specific position. So I will actually set this to, well, marker index. I think that's the best naming for it. And call this .marker index. We also created a new mouse released. So I will copy this line closed as well. And actually we can copy this. So we're gonna call this. And in here we will also say int marker index. So if we're gonna do our mouse release and we want to have it as at a specific marker index, we're gonna say this.marker index equals to marker index. And we don't need the mouse event here. And now this marker index check for if we have reached all the possible positions. We're gonna change this as well. So in here I will now call it int markers placed equals to 0. Since we now also gonna force set this marker index, it's not really reliable anymore because we never know if it has exceeded the size. So here we will say markers placed ++, and this will always be linked to only this grid, while the markers index can be changed if it needed to be X or O. So the markers placed, if it's bigger or equal than the size, then the game ends as well for this grid. Of course, we also don't need to forget to say the markers placed equals to 0 if we gonna reset everything. And let's go back to our ultimate, check if everything is okay. Let's see what's wrong here. Of course, we are not returning the placement we want to have. So for this, I can say placement here as well. And here we're gonna return this basic mouse released. And this mouse released is gonna be, say here, return this specific placement because it was active. And otherwise we're gonna return null, so we don't have a placement. So now in our ultimate we know, in this case, which placement we gonna set, and based on this placement position, gonna let the opponent move relatively on that position. So let's add that now as well. Let's first check if our active X actually is bigger than 0, and our active Y the same if it's bigger or equal than 0. And if it is, it means we have found a selected placement in this case. And then we're gonna find our new grid. So first, let's say for each our grids, and we're gonna find if our grid.getX equals to our active X, and also our grid.getY equals to our active Y. And that means that we found our grid we want to make active. But first we of course gonna check if this grid doesn't has ended yet, because it is possible that there is a pattern found already, or it's like already full, like only in the middle it's possible to have a full grid eventually. And if this happens, everything has to be reactivated again, which is activatable. So here we'll say is game end, and if it is, we will make a new method for this, set grids active. And we will return, so we will break the loop. And if the game is not end in this case, we will say grid dot, we're gonna create the active state as well. So set active to true. And we can copy this and say else grid.set active to false. Yeah, and we're gonna create this set grid active. So let's create this method, and we're gonna loop through here as well. This is gonna be very easy. we're gonna say grid.set active to grid.isActive or is game end, but then it's not equal. So if it's not end, it's gonna be active. If the game is ended, it cannot be activated anymore. So let's create this method to set active. And we'll say isActive equals to, well, B in this case. Oh wait, let's actually rename this to isActive2 and rename this to this.active. It's active. And we're gonna add this variable. So in here where we also have the game end, we can say private boolean isActive equals to true. So they will all start as active. Add some space or enters here, some readability. And for the render then as well, I want to have, if it is active, we want to have like a background color, so we know which grid is playable. So here we'll say draw active background with our graphics render. And let's root this in an if. So if is active, we're gonna draw this background. Let's create it. And here we will first set the color. So graphics render that set color. I want it to be this green type color. So I will just copy paste it here. It's this color code. And then we will fill the rect. So graphics render that fill rect from our start X, start Y. And this is going to be our size and size. And then we're going to reset our color to white again. So I will just basically copy paste it from here. And this will make all our active grids a green background. Let's see how it looks. Oh, it looks pretty fine. But now we can see here, we can only place here. Still here, there's still movement, so we have to fix that as well. But we have now a clear indication of where to make our moves for our Tic-Tac-Toe Ultimate. So this is already pretty nice. Also one thing I actually want to try and check. I think it should work if we're gonna make this rows to 4. So if we're gonna increase it, what will happen? Look, we have an even bigger Tic-Tac-Toe. And it still works as it's supposed to. It's pretty fun. Okay, let's continue. I will remove this back to 3. Now, as you saw, we could still place markers even though we weren't allowed to place that markers at those positions. So let's block movement if we are not active. So for the movement, instead of the mouse moved, if the game is end, we're gonna say is active. So if it's not active, we are not gonna check the collision for the placements and such. And I think that's about it in this case. Let's see how that's working. Now it's never. Sorry. Of course, we need to check if it's not active. We're gonna return. So now we can first place in any of the positions. Let's say here. I cannot move anywhere here. Let's put it in the top. And that's all working. So now we have this working. Let's focus on our main grid, because that's now which is not rendering. Let's see if I can quickly find a pattern here. Yeah, as you can see, we found a pattern, but there's no O here. So let's add that to the project. First, we will need to update and render our main grid. So for here in the update, I will say, wait, we're gonna update it after our grids. So main grid update. And we're gonna render here as well below the end game overlay. So main grid render. But I think this will have a problem because we have the active background. And as we can see here now, it's even gonna draw everything. So now it's gonna draw on top, which we don't really want. So we're gonna remove some parts from the grid as well. So I will create a new constructor. and I will say public grid with our X, Y size, but also add new booleans to say draw grid and boolean to draw our draw our active background. So here we will first I'll call our other constructor, so we don't need to copy paste that code. So we will say this.x xy size, and for here I will now create the new booleans to draw the grid and draw the active. Oh. Now we can say this.draw grid. Oh, this.draw active equals to draw active. Same for the grid. Sorry. And now in the render, we can check here as well if we want to draw the active background. So if draw active is true, let's set the bases here to true equals to true. So basically we're gonna set them here false, but that's how we're gonna override them without changing this logic. And we also need to do the same for the render grid. So this is be called here, and we're gonna say if draw grid, we're gonna do this render grid. So now let's change in the ultimate where the grids are created. So for the main grid I will say false and false. So it will only draw the markers in this case. Let's see if this works. And now let's try to find a pattern. Now we have a big O here. And now let's also see if we can play here again. And as you can see, because there is already, this game is already ended, now all the other positions are open. So we can continue playing. Here. And also check the X here. And it seems to already work pretty fine now. Let's try to get a match here. And O is 1 even. Wow, so that's now all working. That's pretty cool. And that also really shows that from the previous episodes, if we're gonna make it all flexible and reusable, we can get pretty quick to results as this, as making a whole new game from a basic concept. There's still one problem. If I move over here, we can still see all the grids updating, so I can still play even though the game is end. So let's fix that quick. So in the mouse released, or in the mouse move, I have to say here we're gonna first check if main grid, that is game end, we're gonna return here. And I think for the mouse released, we can also check if our main grid, that is game end, we're gonna do the end game here, or they're gonna do the reset here. Say reset, and we're gonna define this as well. So let's loop here through all the grids for each. And grid.reset. And also say, oh no, we can do that in the reset actually. So go to the reset and set the active state also to false. Or to true, I mean. And now we only have to reset the marker index here. So marker index equals to 0. And let's move this all the way to the bottom. Let's try once again. And access 1 and I'm gonna play. So that's now all working. Of course the reset is not working because the game end has not been reset. Let's see what's going on. We do check if the game is end, main grid. But we are not resetting the main grid here. So main grid dot reset. Let's try once again. And now we have won again. Let's check if we can win. And there it is, we can start all over again. So that's pretty cool and all working as intended. We can now also focus quickly on the AI. I will not go too in depth. We will just keep on using our Minimax algorithm for this, but not having the Minimax keeping in account the main grid. So all we're gonna have to do is let the Minimax decide on trying to find the winning pattern in each of the smaller grids. So therefore we can add the AI here. And we're gonna say AI equals to new AI. And because we previously added the grid to this, we now gonna need to support multiple grids. So therefore we'll now add a new constructor to have an empty constructor. And we will only add the Minimax here. And in here I will just say this. So if we eventually want to use this again with the grid, we still can, but it will then just create the Minimax by this. And I will create a new set grid. So here we will say public void set grid, say this dot grid equals to grid. And now in our ultimate, even though we have created our AI, it doesn't know which grid it has to check yet. We always gonna update the AI, of course, as well. So update. Also one thing we of course have to check is we're now gonna define the turn from the grid. So we're gonna remove that as well. And we're gonna say here as well, private int current turn. We start with 0. And we're gonna set this turn as well. So, well, maybe instead of set this grid, I will create it set turn from the grid with the turn as well. And then this current turn equals to our turn. So then it will set the turn based on that. And I think we also gonna need our main grid. Just so we can check if we have a win here too and apply it to the main grid. So maybe for this grid, instead of this new constructor, which we actually just created, we can remove it and not call this empty constructor and say this main grid is our grid. And therefore here we're gonna check if grid dot is ended. We're gonna say our main grid dot place marker from our grid dot x and y. And we're gonna set our current turn. Oh no, our grid dot get winner. Oh, I'm sorry. Not the if the game is end, but if the winner is bigger or equal than 0. So that's actually basically the same as we've done here. Right here we're gonna do main grid now, so the arrow. But it's now basically the same as here. If there's a winner, we're gonna place the main grid, and we're now gonna define the AI with the main grid as well, so it knows where to place. Now we were gonna define when it's the AI's turn. So when the mouse is released, we kind of check if the marker index is gonna be 1 in this case, so O is gonna be the AI. So after here, if everything is set, you're gonna say grid dot if marker index modulo 2 equals to 1. It means it's O turn for our AI. We're gonna say AI dot make move. But now we're gonna also add our grids. And we do this so we can also define on which grid we can move from. First, we can also check if like this set grids active has been called. I will change this to break now, since if it's return, it will return the whole method, the whole method. But we want to break the whole for loop, and say here boolean multiple grids active equals to false. If this set active is going to be called, we're going to say multiple grids active is going to be true. We're going to pass that here as well. And with this boolean, with this new make move we're going to make now, we can define if we first have to check on which of the open main grid positions we can move to, and then move to that grid. So let's create this. First, if multiple grids active is true, we're gonna add a to do here to say find perfect spot. Now in our main grid, and else we're gonna move to our move in current active grid. So in this case, we will actually create a new make move. I will create this private one. Oh wait, we already have this one, I think. No. Grid, and then the grid, and we will say this dot grid equals this grid, and we're gonna say make move. Oh, I forgot the equal. So what it now will do, it will set the grid and then make the move. So here we will loop through each of the grids and say if grid that is active. Oh, we don't have the getter yet. I will first write it out. We'll make move from this active grid. And let's create this getter is active. Move this. So now back in the AI, we're first going to check here from our main grid. So let's say our int best main grid move equals our main or minimax dot get best move from our main grid dot get markers, and our turn. Wait, this set turn is gonna be obsolete this way. Got current turn, and then here say turn as well. And we also have to, well, I can actually remove this and we can still use this set turn. So we can say set turn from this grid and this turn. So now, and maybe it doesn't need to be public, but let's leave it like this for now. Now we found our best grid move. We can say here set turn from our grids dot get and then the best main grid move, and we also can set the turn, and we have one too much here. And well, let's see if this is gonna work. First we have an error here. Of course, we need to have the marker index. And now it will first check if it has multiple active, and if so, it will define on where it will place its grids, and otherwise it will find the first active grid. Also, we can first check if the AI is gonna move. So for the mouse moving, here, if main grid is game end or AI that is moving. Let's see. Oh, of course, we forgot to say make move here as well. Well, basically we're gonna need them anyway in both situations, so let's do one make move call. Let's see if it's gonna work now. Cannot place, and now X is placed. We still have one problem. I still placed an O here because we are not updating the grid index here, or the marker index. So let's apply, or let's change that as well. So if it's gonna be the AI make move with the marker index, we can still update the marker index here too. Just so after the AI is done and we can play again, this marker index has been updated as well, even though the new one is placed, but it's gonna place it based on this marker index before we add the new one. So let's see. And now we play X. And now we can play tic-tac-toe against the AI. And we can even now probably also win from the AI. I saw a problem here that it's still playing sometime with the wrong move. Let's see what is going on. We are not setting the current turn here as well, so we have to place marker. But here we need to add the current turn too. So in the grid, if there is a marker placed, it still needs to update this marker index. So we have this move index. But let's add the int marker index here too. And of course, because it's now overlapping this too, let's basically remove this then. And let's say we're gonna create a new setter here. Void set marker index. Split this up, marker index equals to marker index, and add the marker index here. Integer. Not really a big fan of this. It's not the most beautiful solution, but let's use it for now. And I will add it here so it has no dry code in this case, if you want to set the marker index. And here too. And now let's go back to the AI and I'll remove this current turn and also say grid.set marker index to our current turn. Now let's play again. As you might know, and I didn't know in first glance, we have a little problem. If you're gonna place if our AI is gonna place, as you can see now it plays one in the middle, but we are not updated to the middle. And this is because the AI is not making the move to our, or is not setting the main, or is not setting the active grid after it's placed its marker. So in this case, let's move this logic out of here. We're gonna say, and we're gonna create a new method for this. So let it return a boolean for the multiple grids active. Set active grid, and then for the end X and end Y, or let's say active X and active Y, and paste. And here we're gonna return true, and otherwise we're gonna return false. So we also don't need to have the break, and we don't need the equals true. We're just gonna return true. And here we're gonna say the booleans equals to set grid active from our active X and active Y. So what I will do for now, normally I will make an observer for this, but I don't want to get too much in detail for that. So we can add the ultimate here as well, just for our easiest sake. And we're gonna say here, when we create our AI, add the ultimate. And say ultimate equals to ultimate. And then if we're gonna place the marker, we're gonna check on the best move. So the X and Y from here. So let's say in move equals to minimax move. Okay, here move. And say int X equals to move modulo main.rows. And int Y equals to move modulo, or this modulo and the other divided by main.rows. And then we can also say our ultimate, and let's see, how did we call it now? The set active grid, we can make it public. And set active grid to our X and Y. So let's see if this is gonna work. Let's see if there's any error here. We have one. We add this. Let's hope it's now gonna work. And now it seems to work much better, or actually, especially how it should work. And I think we now even can win as well from the AI. Even though it always tries to, well, find the best possible solution. Let's see what is best. Let's see. Well, let's give O here one. And we have one. So that was it for this tutorial. I hope you enjoyed it. And if you did, please consider giving me a like and subscribe. And put up the bell notification to get notified for the next episodes. I also hope you have now a better understanding of Tic-Tac-Toe Ultimate and that you can create big changes to a simple mechanic if you set everything reusable and flexible as we have done in the previous episodes. Currently our AI is far from perfect, because we didn't add the strategy to our Minimax to make moves and try to predict winning the main grid. But that's quite a fun challenge for you too, so if you think you're up for it, I would really recommend to try it. For now, I hope to see you in the next video, and if you have any questions, always feel free to ask in the comments or send me a message on Instagram. Goodbye!